So,
Okay, so good afternoon, everyone. It's afternoon here in Kenya, but maybe in other parts it's morning, it's midnight. Well, let me welcome all of you to our today's uh, virtual talk titled Kenya Climate and Climate Change that will be presented to us by Peter Usher. My name is Richard Kipngeno. I work here as Nature Kenya as a birding and membership officer, and I will also be the one moderating today's talk. I will request each and every one of you that we remain muted so that we give the speaker ample time to complete his presentation, and also to let you know that we are recording this presentation, and later on we will upload it in our Nature Kenya YouTube channel, which you can revisit and learn more from it. And I will also urge each and everyone that we raise our questions, our concerns through the chat box, and we will strive our level best to go through all of them at the end of the presentation. So just a quick introduction to who our speaker for today is. Peter Usher is a meteorologist who came to Kenya in 1962 as a British technical aide to East Africa. He assisted the Kenya Meteorological Department for 20 years before joining the newly created United Nations Environment Program to work on ozone layer depletion and climate change. He was chief of UNEP's atmosphere program until his retirement. Peter's hobby is bird photography, and he has generously shared his images with us here in Nature Kenya and really features in most of our publications. So ladies and gentlemen, allow me to bring on stage our today's speaker, Peter Usher. Welcome, take us through.
hello, everyone. Yes, I am indeed Peter Usher, but this is not me on the screen. It is a computer-generated image that looks a bit like me. But today we're going to look at, first of all, we're going to look at the climate of Kenya, and then we're going to look at regional events that affect the Kenya climate and are very important to the climate of Eastern Africa. And then we're going to switch to climate change and look at it from a global perspective. And if we can, translate some of those thinkings to the Kenya situation. So first of all, we're going to talk about Kenya climate. And as those who live here know, there are 4 seasons. We start the year with a hot, dry season. Then by late March, we are into the long rains. Then there is a cool season, and it is the cool season that we're in now. And I believe today might well be, for Nairobi, the coldest day of the year so far, although it is not as cold as it might be in this time of the year. And we finish the year with the short rains, and the little graphic at the bottom shows you the annual rainfall average with the long rains on the left and the short rains on the right. Specifically looking at that, in January, this is the reasons for these seasons to occur, that in January, pressure is generally high over the Mediterranean and Europe because it is the winter there, and the very warm water in the southern Indian Ocean generates low pressure, low enough sometimes, or frequently even, to produce tropical cyclones. The wind flow is from Arabia down across the equator, Coriolis force turning it to a northwesterly into the low pressure. So the winds are coming from desert areas, accelerating divergent sunny conditions. Occasionally, the cyclones will cause troughs big enough to affect us in East Africa, and we will get periods of rain. It is not the dry season. The driest season is indeed this time of the year. If you look at the April graph, the one on the right, then you will see the changes as the Indian Ocean cools in the south, then high pressure forms, and you get southeasterly winds meeting the northeasterly winds. They are convergent at the equator. This is what you might know as the intertropical convergence zone. It is an area of usually wet, thundery conditions. July, as we are now, the anticyclones in the south are getting stronger. The ones in the north are weakening and becoming low pressure. So we are dragging air from the Southern Ocean, from Antarctica, cold air, picking up a lot of moisture as it crosses the ocean and brings cloud and mist to the equatorial areas. It's not deep cloud. In fact, it is very shallow cloud. The cold air tends to undercut the warmer air over the continent. So you get this thermal inversion and lots of cold, cloudy times, but generally dry. In November, we just revert to a situation of the April-May time. It's the time of the short rains. Again, northeasterlies, southeasterlies, convergent at the equator, the intertropical convergence zone, a very active weather-producing mechanism, and indeed rainfall again. There are many local and regional features that modify that weather. If we had the standard climate, what I had just described to you is what you would get. But there are a lot of things that modify the weather that we have. Lake Victoria being the biggest one. If we didn't have that lake, we would have a totally different climatic regime. You get big thunderstorms over the lake during the night and morning, and as the sun drops the pressure over the Rift Valley in Western Kenya, then you see the thunderstorms moving in the afternoons away from the lake. We've got a whole lot of things here that I needn't describe. Most of them are self-evident, particularly those at the top, orographic effects, air being pushed up over mountains. But we do have some very interesting phenomenon that seriously affect our weather. And let me tell you that if you listen to my biography, I was a weather forecaster with the meteorological department up at Dagoretti Corner for 20 years. And these features, Indian Ocean dipole, the El Nino and La Nina events, were something that we had never heard of and certainly didn't come into my reckoning when we were doing forecasting. And of course, there was also no satellites in those days. And my tools for forecasting was a very sharp pencil and an empty graph. I don't want to go into the detail here because I don't think it's important unless you're talking to meteorologists, just for you to know that there are major events that have the ability to significantly affect the East African climate and weather patterns. And we'll look in more detail at one of those, and this is the Indian Ocean dipole, where it was discovered that you got you could get upwelling of warm seas in certain parts of the ocean, and cooler events in the other extremity. This when it's warm off the Somali coast and the East African coast, that's a positive Indian Ocean dipole, and what it brings is a lot of vertical motion in the atmosphere, a lot of storm clouds forming, and rain. And where it is particularly looked at is in Australia, where the dipole will cause significant drought. It lasts usually for 1 to 2 years, perhaps, and occurs every 2 to 7 years. So using satellite information, we can observe when the Indian Ocean dipole occurs and in what phase it is occurring, and the obvious consequences in weather patterns that fall from that. At the moment, it is in a neutral phase, but there are signs that it is warming. And as you can see from the graph here, a positive Indian Ocean dipole should bring us rain during the short rainy period. The other factor of perhaps even greater importance, and one you will again be familiar with, is the ENSO pattern, that is El Nino and Southern oscillation. It fluctuates between an El Nino event, which is the lower graph, warm water in the Pacific, warming the ocean to the extent that it has the ability to alter the whole global pattern of weather. And we have gone over the last 3 years through a La Nina phase, which is the opposite of El Nino and is represented by cold air in the Pacific region, in the Pacific near the South American continent, and then warmer air towards the Philippines. La Nina, and I'll go into the next slide. Or not. We're stuck for the moment. I don't know why. And everybody has left the office. We have a problem. I can't move. And next one, okay. Here's a representation of El Nino. You can see that air descends over Australia, giving those dry drought patterns with forest fires. And for East Africa, you can see the large cumulonimbus clouds that can result in prolonged and very heavy exceptional rain. And we have instances of most damaging weather events. We are now in the early stages of an El Nino event. What that should mean for us, but not necessarily so. We have been deceived on a few occasions, but generally El Nino means wet weather over East Africa. A weak El Nino would probably make little difference from the normal short rainy season. But a strong El Nino, and we are now talking about the potential for a super El Nino, which has occurred before and can cause catastrophic rainfall. The one that you may remember, if you're old enough, in 1998, where the rains not only was exceptionally heavy through November and December, but continued into January and February, the so-called hot season, and joined up with the long rains of the following year. And we are, as I say, going into a strong El Nino phase, and at the same time we are possibly going into a positive Indian Ocean dipole, and there is evidence that they do reinforce each other. So we may be on the cusp of a very significant weather event, and we'll come back in November and we'll talk about it and see whether we were right or no. But indeed, El Nino may be well the dominant feature of the months from almost now to the end of the year and into next year. The last major El Nino was in 2018, 2019. And here's an indication of how the rainfall varied from the average amounts, with blue being exceptionally higher rainfall. You see the rainfall anomaly of 300 millimeters in places there in Kenya, and affecting, as it does, Ethiopia, Somalia, Kenya, Uganda, Rwanda, and Tanzania. It does not affect South Africa in the same way. They tend to have a drought rather than the heavy rains that we experience here in Kenya. There we go. That particular event caused significant hardship in all the East African countries. And if you look at Kenya, the number of deaths was far higher than in anywhere else in East Africa, although the number of people affected may have been a smaller number, with Somalia, Ethiopia, with half a billion people being affected. Kenya did tend to suffer quite significantly from that event. A few pictures I took during that time. This is Lavington, where I live, and the river overflowed. And to the extent that pedestrians and traffic could not easily pass across the small river that flows there. If you look at the lower left-hand side picture, pedestrians are crossing on a tiny little walkway across a raging torrent flowing down into a culvert. And during that particular time, one of the passers-by happened to be rather drunk and fell into the culvert. And we thought that was the last we would ever see of him, because it's a closed culvert which stretches half a kilometer to the north. And surprisingly, he appeared an hour later, where he'd managed to get himself out of the flood without dying. So he wasn't one of those people on the statistics in the last slide. Here's some more pictures that I took at the same time. James Gachuru Road didn't do my camera any good, but that was the state of the roads during the floods. And Paboni Road, there's a gentleman earning himself a lot of spare cash by guiding traffic through the floods that occurred. But the newspapers, the media, people, and the government had little understanding of what was actually happening. And I collected a set of newspaper comments on one of the El Ninos. This is actually a strong El Nino before the one that I just talked about, where a lot of money was put aside to prepare and respond to that active El Nino. In fact, it wasn't quite as heavy as it was that we perhaps expected, but even so, it was fairly dramatic. But the government put aside many billions of shillings to respond to it, but it gave also an opportunity for a significant amount of money to be misdirected, shall we say. I know you can't read this, but some of the highlights was the government buying soap for victims of the rainfall at 37,500 shillings apiece. 50 million shillings were put aside for unnamed tasks by the cereals board. 50 million shillings was to carry out sensitization of disaster preparedness for fish farmers. They were all a bit odd, and one doesn't really know whether those preparations did much good. Certainly the money seemed to have been less well spent than it might have been. This is a very new chart, and I'm not an economist and I can't explain the reasons why. So you might wish to offer a comment rather than ask me a question, because I don't know the answer. It looks very much that East Africa's GDP is going to be more significantly affected than many parts of the world. And remember, that is not just for this year. This financial problem is expected to continue for several years before there is a recovery from the damage done by a significant El Nino. I'm surprised that Australia seems to shrug off the issues, even though El Nino does present them with a major drought problem. But it gives you an indication that there are not any winners in ENSO events. They are disastrous events that are disastrous phenomena that we are now luckily at least able to forecast, if we are still a little uncertain on how we might respond to them or adapt. As I said, this was the last El Nino, and we are on the cusp of another one. Now let us switch from local conditions to the global situation. You came here for climate change. This is climate change. If you don't understand what the greenhouse effect is, this chart does a job of answering that. What we have is solar radiation from the sun. It is shortwave radiation, and the atmosphere is transparent to incoming radiation, some of it which bounces off back into the atmosphere. A lot is absorbed by the Earth and re-radiated as long-wave thermal radiation. Now, if greenhouse gases, that is, we'll come to that in just a minute, but the greenhouse gases in the atmosphere absorb and re-radiate back to Earth that heat that is should be going to space. And the more greenhouse gases that you have, we're looking on the right-hand side at this moment, then the hotter it becomes. And the cause of greenhouse gas increases is chlorofluorocarbons and halocarbons from refrigerators, aerosols. Not so much of a problem now because of the Montreal Protocol. You may be familiar with the Vienna Convention on the ozone layer and its Montreal Protocol. Then there is gases, the nitrogen gases from agriculture, and methane, probably one of the most virulent of the greenhouse gases. Methane, it's a short-lived gas. Luckily, it doesn't stay in the atmosphere too long, but its effect is very, very significant, and it is increasing in volume in the atmosphere. A lot of the permafrost in Northern Europe is now releasing methane at a vast rate, adding to the industrial processes that also produce methane. And of course, the one that we all know about is carbon dioxide, oil and coal, big oil, and the hunt goes on for creating more coal mines. I read yesterday that China has opened more new coal mines this year than in the whole of last year. However, on the plus side, they are the leaders in processes to produce safe energy from solar, wind, and wave production. Now, this is the three nearest planets to the sun, and Venus has a thick atmosphere of carbon dioxide and a temperature of plus 420 degrees centigrade. And it's all due to the greenhouse effect from that carbon dioxide atmosphere. Mars, the one furthest on the left-hand side, has all of its carbon stored in the land, and there is very little carbon in the atmosphere itself. So the temperature, of course, you also have to factor in its distance from the sun, but it is an average temperature of minus 50 degrees centigrade, while Earth has an average temperature of 14 degrees centigrade, but that Goldilocks temperature can be attributed to the greenhouse effect. The natural amount of carbon in the atmosphere keeps us warm and happy, where without it, the temperature might well be minus 20 degrees. But we are changing the composition of our atmosphere. We're continuing to put carbon in large quantities, and the consequence is the greenhouse effect is producing global warming. Back to my artificial intelligence produced pictures, a little pause, an indication of who is causing or what is causing this change in our atmosphere. It is now without a doubt confirmed that the cause of global warming is the anthropogenic emission of greenhouse gases to the atmosphere. We are doing it. We are about to reap the consequences. This is an interesting graph, again, a fairly new one from the Intergovernmental Panel on Climate Change. It shows the increase over the year. It doesn't show the absolute carbon dioxide, just the change from year to year, the increase in concentrations of carbon in the atmosphere. When I gave this talk 2 weeks ago, I was asked why there was that dip around the 1990 period, and I didn't know the answer to that. I wondered, I've thought about it since, and wondered whether it was a consequence of that major economic downturn that began in 1988 and possibly a lot less energy was used as a consequence. But if any of you have an idea, please tell me. I would love to hear it. Again, the COVID outbreak reduced the increase in carbon in the atmosphere, but it didn't make it a major downturn. It's still certainly going up through those years where we were all locked down, still going up at more than 2 parts per million. So who's doing it? Well, all of us, of course, but we can ascribe 1/3 of the emissions to the United States, the European Union, and other developing countries. We have another 1/3 emitted by Russia, China, and India. And then the rest of us produce a final 1/3. Certainly, with this being a graph over time, you can see that we are throwing an enormous amount of carbon into the atmosphere when we have been told long enough ago that this was not a good thing to be doing. I can tell you that when I joined UNEP in 1977, my main task then was to deal with ozone layer depletion. And I'm pleased to say we were very successful in that. The ozone layer is significantly recovered and still recovering and safe as a consequence of what UNEP managed to get the world to do. But my next task was then to address the issue of climate change. I was very much involved in the early assessments of global warming with international conferences that I organized in 1980. That conference in Austria in 1980 made the assessment, made the statement that we were facing a catastrophe equivalent to second only to thermonuclear war. And here we are, 2023, with the threat of nuclear war from Ukraine, and also very little action to limit greenhouse gas emissions and to keep the temperature within the bounds that scientists tell us might be acceptable. And that figure is 1.5 degrees above pre-industrial times, we are currently 1.1 degrees above pre-industrial times, and El Nino is a global warming event, admittedly a temporary event, and of course a natural event. But we are going to break that 1.5 barrier within this year. This 2023 may well be the hottest year on record. A lot of hot air has passed within the diplomatic fields to produce plans, strategies to limit climate change to this mythical 1.5 degrees. In fact, if the Paris Agreement was initiated in full, then we would still be talking about 2.3 degrees centigrade rise above pre-industrial levels. This cartoon, incidentally, is also produced by artificial intelligence. I asked it to write me draw me a cartoon suitable for this presentation, and this is what it came up with. Right, this is a very interesting graph, I think. It shows how CO2 has increased in the atmosphere through anthropogenic emissions, going back from 1850, pre-industrial times. Then since then, we've just filled the atmosphere with greenhouse gases, particularly carbon from coal and oil. And if we stop today, and today is that peak before the dotted line, if we said we will not emit any more carbon from today, the graph would follow in a downward direction. But if you look at the shape, it will take at least 100 years before it even recovers to the current concentration of carbon in the atmosphere. The plan, of course, is to delay emission reduction for another 20 years, and that is the dotted line. And then we are talking about centuries for the carbon to recover to current day levels, certainly not anywhere near pre-industrial levels, which we may probably never reach again. I did have another graph showing sea level rise. The shape is essentially the same, but because of the inertia of the oceans, it would take millennia for us to return our ocean temperatures to current values. Just a graph showing the relationship between carbon dioxide concentrations in the atmosphere and temperatures. This graph was derived from proxy data, that is lake sediments, tree rings, ice cores, and so on, and plots fairly accurately how much carbon was in the atmosphere at any particular time over, I think it's 400,000 years ago to the present day, and shifts in carbon are matched mirror fashion with the temperatures. There are those that will tell you there is no relationship, but it is true. Here we go. This is our temperature rise since the 1900s. Few fluctuations due to natural causes, but you can see the trend. That's all you need to look at is the trend that we are aware of. the trend that we require to stop if we are to survive a climate problem. And with 2016 being the warmest year on record, 2020 almost matching it, and 2023, as I suggest, will be the year to surpass that peak. Again, I only need you to look at the trends here rather than any individual feature on these charts. The top chart shows how temperatures have changed in different regimes within the world. And the bottom chart shows sea level rise at some important ports within the world. You can see the trend for temperature is upward, the trend for sea level rise is upward, and it is we are responsible for that, and we should be responsible for changing the direction of those trends, and we are significantly failing to do so. As the cartoon suggested, too little, too late. Here's an indication of what the temperatures will do if we do nothing, or if we fulfill the pledges that were made at Kyoto. I was at Kyoto, incidentally, just before my retirement, and Paris. You can see temperatures getting close to 3 degrees. If we continue with current policies, then we will be looking at 3.5 degrees rise in temperatures. And if we do nothing at all, and it's business as usual, then we exceed 4.5 degrees. That is the global average, not the average at any point in the globe, because what might be 4.5 on average might be 2 degrees at the equator and 7 to 10 degrees in the high northern latitudes. Right, again, this is a graph indicating what happens if we don't take immediate and significant action. There is not a region on the globe that is not impacted by global warming. You might want to pick your future home where it isn't quite so bad. The worst, of course, is in the extreme north, with temperatures up to 10 degrees. Kenya looks like a good bet for the climate refugees to move to. Certainly, we perhaps have a more benign climate than many parts of the world. I guess that's why a lot of us are here. Yes, I digress to my AI-produced pictures, and look at your future and weep. Again, we've more or less seen this picture before. Again, Kenya, Tanzania, Eastern Africa, less affected by the global warming that will come. If we can act as we should, then the top graph suggests that we can keep the change under manageable conditions, but the bottom graph, business as usual. As we pass 4 degrees, most of the world becomes difficult to live in. In fact, this will show you exactly that. I had a lot of these graphs, but they were a little bit too complicated to put on a screen. So again, I'm going to just tell you what's there and just require you to see the trend rather than the particular detail of the chart. The top chart is on the risk of species losses. The investigations, the research has been done on over 30,000 species, and it shows scenarios for a modest rise of 1.5 degrees, 2 degrees, which is the more likely scenario. And if we're careless, the 3 and 4 degree scenario will become our future. And the purple shows the potential for extinction of natural resources, wildlife, trees, the biosphere. That purple is 100% destruction, something we must view with absolute horror. And a similar graph on human health, the risk to human health on the bottom, it shows how many days that the temperature might exceed that directly affects human health. From the 1.5 degrees, well, the first one is 1.7 to 2.3 degrees, and certainly equatorial areas, particularly it seems in Latin America and Asia, there will be days where half the year might have conditions of humidity and temperature where people might well die if they are exposed. And the other two graphics that with the temperature increasing, look where we are when the temperature gets to 5 degrees, and it certainly was within the possibility to happen should we fail to deal with it. Latin America, Equatorial Africa, and Asia are in a situation where every day of the year, 365 days and 366 of the leap year, is beyond our capacity to comfortably live. What's affected by global warming? You see the top group there, sea level rise, precipitation patterns and temperature, and breaking that down further, health is at risk, agriculture is at risk, forests could die out, and certainly forest fires are already a significant factor. Look to US and Canada on this very week, where the air quality is insufficient for people to venture out of doors. Water resources, the probability is that there will be conflict over available water. Certainly we will require more. Certainly we may well have less to provide us, and it is perhaps one of the more worrying factors that we're going to have to face in the future. Sea level rise will do no good things for Mombasa or Malindi, and there are many places within the world, including islands, that are scheduled to disappear without radical action, and possibly in places like the Maldives, where the sea level and the land height are not very far apart, those islands will disappear completely. And of course, as I said, natural species are at great risk from conditions that have never been experienced before in the world and beyond their capacity to adapt, because things are changing at a very, very fast rate indeed. Coming right back to East Africa, this is a graph produced by UNEP on the effect of 2 degrees centigrade increase on coffee production. The brown is coffee producing areas. Under a warmer world, there is little coffee. Of course, one can adapt with new species and look elsewhere for coffee growing areas, but that is an indication of the sort of threat we are facing. Sea level rise, there's the Egyptian Delta and Bangladesh. Look at Bangladesh on the right-hand side here, where the population is going to drop by 100 million or more because of inundation of seas. And where are these people going to go? Currently going in small boats from France to England, but don't be surprised if they turn up in Mombasa before very long. Glaciers, we have a little bit of ice left upon our mountains, but not very much. Look at the change in ice over the years from 1900 to the current time in the Rwenzori's, Kilimanjaro and Mount Kenya. The visible change should shock you. Here is a set of pictures that I took. The one on the left, which looks very healthy, of course, is not glacier. It is snow from an exceptionally heavy downfall of snow during the night, which was gone by lunchtime. The picture on the right was taken the following day, and that tiny little block on top of Kilimanjaro is all that one can see of the glacier that was so visible before. Freshwater stress, again, it's a question. You might ask the question, why is Kenya particularly likely to have freshwater stress? I'm not sure of the answer to that, except that we are already having a problem with available water. Anybody who lives in Lavington will know no water is going to come through your taps during the day. But we can say with some we can say with confidence that most of the world is going to suffer from freshwater availability within the next few years, the coming years, certainly to the end of the century. And now, what I've managed to avoid up to now is putting words on the charts that I have shown you. But these are the 10 takeaways from the very recent, this year or late last year, Intergovernmental Panel on Climate Change report. And they, if you can read them, you will find them not very welcome. Certainly, we are saying now that human-induced global warming is already here. Certainly, when I was a member of the IPCC, we were talking, there was a possibility that the global warming was induced by people. Now we can say with absolute certainty that we are the cause. Global warming is going to be at least 2 degrees before the end of this century. And as I say, the 1.5 cutoff point that science said was the absolute furthest we dare go will be surpassed probably within weeks of me talking to you here. Certainly not June, July, August, however, because this is our cold season. And as I showed you with that one graph, that whatever we do now, there is an inertia, and it will be centuries, even millennia, before we recover the climate to what we should be pledged to protect. And we have failed indeed to do so. I can't even see this one on my screen, but essentially it says every region is already affected. Optimistic voices say there is still time to limit climate change. Yes, indeed, I believe that, but we have to act fast. We should have acted yesterday. We should have acted in 1980, when science already was stating the fact that global warming and climate change was something that would occur and we would not welcome. We can adapt after a fashion to the risks of climate change, but we can't adapt to everything. Species will become extinct, and we will just have to suffer the consequences, including for the many people, the worst possible outcome, including death. The people most affected will be the developing world, and our ability to prepare for climate change is certainly compromised by our economic positions. But as I said, biodiversity and ecosystems are vulnerable, and people, health, well-being, and security is certainly in danger. And what is the answer? International cooperation, but more than that, it means global action, or we are in very serious trouble. Are there signs that we're doing enough? Well, I think if you study the graphs that I presented to you today, the trend is wrong in every single one of the charts. We have not done enough. We know what to do. We've had the opportunities. We have failed. Well, that's the end of my talk. I hope you followed along, and I'm still in time. Over to you, Richard.
Thank you. Thank you very much, Peter Usher, for that insightful presentation. Actually, all the artificial intelligence images played a very critical role, in bringing in the real feeling and the picture of what is happening out there. So I will open the ground to all our participants. If you have any question, you are free to ask. And going through the chat box, I see Dave Hilliard is requesting, please could you show the AI generated cartoon again? I missed it, sorry.
I look for it, but I've got a lot of them.
That's from Dave Hilliard. I think that was a very impressive cartoon that was communicating a lot. And Margaret Vaz, hi Margaret, how is Canada?
Morning.
Oh, good morning to you. It's afternoon here in Kenya. Yes. And okay, yeah, I see. Okay, yeah, I will give you an opportunity to speak.
Well, it's rather sad because everything you've talked about the fires burning. I'm actually in London, Ontario, in Canada, and we have warnings not to go outside or be outside for too long because we have a cloud of, you know, the effects of the forest fires. There are over 500 uncontrolled burning of forest fires in northern Canada, particularly northern Ontario and Quebec. And really everything you've talked about is happening. But perhaps what I would say is countries like ours who need to step forward have always been lagging behind. And this is a wake-up call because suddenly people are finding it's no longer in your backyard, but it's in our backyard. And we need to do something about it. But it always disappoints me because I can have a conversation with friends and it just doesn't seem to resonate with them yet.
All I can say is you are right. The situation is quite dreadful, and I don't know what it is going to take for us to really come around to agreeing and enacting a global response. When I was dealing with ozone, we had a big wake-up call, and that was the Antarctic ozone hole, which grew to an extent that it was covering Australia as well. And it concentrated people's mind to an extent that the issue hadn't before. And we were able to get quickly to a solution. Of course, there are differences with the climate situation because we had readily available and cheaper alternatives. We don't have the same situation with replacements for greenhouse gases. I've got a problem with my machine at the moment. My battery is running low, it says. I don't want to run out, so I'm going to call someone to deal with it. Yeah.
Thank you very much, Peter Usher, for that input again. Well,
I'm plugged in again, so I'm here now.
Okay, great.
So Peter,
we don't want to lose you at the moment. Okay, go ahead, Margaret.
So Peter, when I think about what's going on, I mean, you have to factor in the fact that, you know, we've been drawing water in our parts of the world as if there was no tomorrow. So the end result is that, in my opinion, part of the forest burning is because of the lack of water. And then we have floods. And, you know, because our trees are being destroyed, there's nothing to catch it. So, I mean, we can talk about countries like Kenya and East Africa, but we're the worst in terms of we have the natural resources in our parts of the world. We're not taking care of it, and it's affecting your part of the world. So all I can do is apologize.
Yeah, I think that's true.
As it is, yes.
Yeah, I think that's very true, Margaret. I live in Northern Ireland, and today it's 14 degrees only and overcast. And people in our area, where we're cool and cold all the time, we don't have the impetus to support the global warming things. And you see here, all you can think about is getting away into the sun. So, you know, how many more places are like that?
Mm-hmm.
Indeed. Well, so much for us to ponder. I think, Dave Hilliard, now you have a very beautiful image of the cartoon. Thank you very much, Peter, for sharing that. And also, another question from Dave. I have known for years that governments are not doing enough, but politicians are so short-sighted and just will not listen. How can we make them stand up and take notice?
It's extremely difficult. As I say, I've been preaching this sermon since 1980, and I have not done very well because people are still not listening. The biggest conference that I was probably involved in before we got to the conference of the parties, which involved thousands of people, I held with the Canadian government in Toronto in 1988. And that was such a big conference. We had world leaders there listening, being shocked, and pledging to do their very best to address the issue. And 88 is a long time ago, and we are not much further ahead, I'm afraid.
Great.
No, because politicians just react to the next vote. Really
Indeed.
not interested in the long term. And
Yeah.
that's the disappointment.
Thank you. Thank you for the input. I think we still have some like 5 minutes to go before we bring the session to a close, and I still welcome it.
We do. If someone's about to help me, we can put on my 2-minute video, which summarizes everything.
Great. Please go ahead,
Yeah.
Peter, if you have it.
I shall pass over now. Wait a minute.
The climate of East Africa. There are 4 seasons: a warm, dry season from December to March, a cool, dry season from May through August, and 2 wet seasons: the long rains in March, April, and May, and the short rains of October until the end of the year. But seasons are changing. The global climate is being affected by increasing concentrations of carbon dioxide and other so-called greenhouse gases in the atmosphere. These gases are byproducts of unsustainable industrial processes and inappropriate agricultural practices. These gases generate heat and keep the Earth's surface warm, but the increasing levels of these gases in the atmosphere are changing the way the Earth's climate works, and the East African climate is changing too. While drought and flood are natural and occasional elements within the climate system, the increasing number and frequency of anomalous weather events is a cause for alarm. The East African climate is cool and dry in the highlands, while it is hotter and wetter in the coastal regions. The highlands are generally cooler and moister than the coast. There is a great variation in temperature, with a range from 18 degrees C, 64 degree F in the highlands to 26 degrees C, 79 degree F in the coastal areas. Many natural phenomena influence the occurrence of anomalous weather. Principal among these are El Nino and La Nina, that briefly involves the effects stemming from ocean temperature differentials in the Pacific, causing global shifts in the natural climate patterns. Strong El Niños induce periods of heavy rain in East Africa, while La Nina is associated with drought. Another important influence is the Indian Ocean dipole, that depending on its polarity, will induce drought or flood. How global warming will affect the behavior of these phenomena is not fully known. What might be the impact of a changing climate on Eastern Africa? Among the possibilities are crop failures, changes in disease vectors, flood, drought, tropical storms, and other events unlikely to be welcomed, and with probable adverse socioeconomic consequences. So what can we do to protect ourselves? In short, we must work together with the global community to reduce greenhouse emissions to an extent that the projected rise in temperature remains low and slow enough for people to adapt. If we do not do this, we face a catastrophic future. Thank you. I am Pete, and I am an avatar.
Thank you for that. Awesome.
Yeah.
Thank you, Peter. Very impressive.
Yeah. If I'd had more money, I would have cloned my voice as well as my image, but I didn't. So I took a free voice.
Well, you were very handsome anyway. And I remember you in the birding days, and what a lovely time we had leaning on your expertise.
Thank you.
So-
You. Yeah.
Thank you very much indeed. I've enjoyed being here.
Thank you. So maybe, is there anyone with any other burning question before we bring the session to an end?
Well, I'll just make one comment if I may.
Please
And I
do.
think, honestly, Richard, you know, by you bringing something like this as part of Nature Kenya, you have a huge impact within your country, and you should feel very proud of that, because you are the future. You are the future, and thanks to people like our speaker today, you are the voice of the past, but you're also the voice of the present, and we draw on everything that you have learned. And, you know, I think that a place like Kenya, where you've presented today, can have such a huge impact just within your own communities. That's what changes the world. It's not us here who believe that we can keep going the way we used to. So honestly and truly, I believe change happens with our youth. And when you look at the world's demographics, the largest percentage of young people are in Africa, and you are our future. So please believe that. So thank you.
Thank you. Thank you very much, Margaret. Thank you. We really appreciate. Thank you very much. Any other comment, compliment, maybe?
Thank you. Plenty of compliments in my head.
Thank you. Thank you very much. Thank you very much, everyone, for taking your time to join us virtually for our today's virtual talk that was excellently tackled by Peter Usher. He had said initially that this is his first Zoom presentation, and he has done an excellent work. Thank you very much for that. So I wish you a very nice weekend ahead, and see you soon virtually again for another engaging session. Thank you.
Thank you. Thank you, Richard, for your smile.